tell us about what's going on. What's important stuff we need to know? There's a lot of activity right now.
Sure, yeah. I don't think it'll take that long. I'll just share my screen and show the GitHub issue. Can you see that? So I've just been debugging or a memory leak that was introduced a couple weeks ago. Actually, this was the like AOT autograd changes from a couple weeks ago that deal with graphs that have outputs, tensor outputs that alias like graph intermediates. And there's this like extra stuff that AOT autograd has to do in that situation, where basically, like instead of the compiled graph just returning the output, it also returns the graph intermediate, and then we regenerate the aliased output off that intermediate in this like stashed epilogue after we run the graph. And so that was the AOT autograd change, and it caused like an out of memory on this one specific model. And I finally have like an open source repro for it, and it's pretty complicated, and it's kind of weird because I can't actually make it any simpler without the memory leak going away. And it's just some weird interaction of like, you have some tensor that you take some weird views on, you call a custom autograd function on it, and then you graph break, and then you return like some stuff that was used in the autograd function in the previous graph in some way. And that induces a memory leak. So I guess that's more of like a PSA, but I'm just looking into that now.
Um, One question I would have is anyone, can anyone share the latest and greatest on how the custom function is handled at the Dynamo layer?
To be clear, this is an
Um,
unrelated question, right, Alvin?
Well, I see a custom function, and Brian says that removing it removes it, so loosely related.
Oh yeah, it's true.
That's true. When I remove this graph break, the memory leak goes away. So you're right. I should double check. This is actually causing a graph break too, but that would imply that it's not. But I should take a look.
So we don't always graph break on the custom functions
Yeah,
anymore.
we only graph break on custom functions if the inputs require gradients, like if it's necessary to run the backwards later. I think that's the current state in Dynamo.
Okay. Well, we can discuss that later, I guess, if you have other topics.
Okay,
Yeah,
so this is an
that's sure.
Brian, there's also still some activity going on with batch norm and functionalization and inference. Can you summarize what the status there as well is?
Yeah. Um, so the issue with batch norm that Horace found yesterday or 2 days ago was um, so a batch norm consolidation effort would be really great. We have a lot of batch norm ops and they need to be cleaned up. And like the current quote unquote problem with one of the batch norm ops is one of the operators that we trace out as a primitive in the graph advertises as having a mutable schema. So it advertises as its inputs are getting mutated by the op. And it actually, the inputs only get mutated under certain circumstances. So there's this training flag that you pass in, that's a Boolean. And when training is true, we do mutate. Else we don't mutate. And so because all of this logic with functionalization and like when we detect input mutations is entirely based off of the schemas of the operators, then we see that up in the graph. Functionalization assumes that the inputs are mutated and it adds a bunch of extra copy underscores to the graph, even though in the inference case, the mutation didn't actually happen. And so there's like a hacky fix that we have before the release, like to just get into the release for now, which is further decompose that existing op into like two smaller ops, one where training is true, one where it's false. So we can like have a separate schema for a new op that knows when like these inputs aren't actually mutated. And then that's the thing functionalization sees, and then there's no extra copies in the graph. And that works. And also it's really ugly and we should clean up batch norm.
Okay, and that's everything, right? Besides that, functionalization on inference is on, and it looks like it will be in the release. And these are the only two
That's right.
issues we're
I
tracking
think
on
one
right
other,
now.
yes, the one other small thing is there's like an existing inductor bug where if you like take weird slices of some input and then mutate them and then the copy underscore at the end, you get wrong results. And I don't think that shows up in any of the optimizers, but there's like a GitHub issue for it.
Okay, Sounds good. Thanks for sharing, Brian. Is Voz
Do
here?
those,
I don't. What's
sorry
up?
to jump in. Do those issues have the like release tag on it or part of the milestone?
The inductor copy underscore bug, no. I don't actually know if we want to fix that for the release or not. The other bug, it doesn't, but it's high pri. So the memory leak bug.
We are not fixing the copy underscore bug for this. It's probably pretty involved. And branch cut should have happened already.
It did.
Okay, thanks for sharing. So Voz is still not here, but all of the other topics that we were going to talk about are for the second half of the meeting. So I'm just going to go ahead and present Voz's doc. I helped make the doc, so I don't feel bad about doing this. So this doc is about 0-1 specialization problem in PyTorch 2 export. So the basic context for this is, hey, we're exporting models. We want to export them with dynamic shapes so that we don't specialize on the batch size being 8 or whatever. You can vary it in your export model. And you can do this, and you can even check that there are no guards on the batch dimension. And you might think to yourself, hey, that means that I have a model that works on any batch size. But you'd be wrong. And the reason you'd be wrong is because actually we also do something called 0-1 specialization, which is we just assume that any dynamic dimension you have is not 0 and is not 1. And so if you would have generated guards on it being 0 or 1, we actually just, do those control flow paths as if it couldn't possibly be 0 or 1, and we don't bother generating guards. So in fact, technically, when you export a model today, you get a model that works for any batch size as long as it's not 0 or 1. Now, 0 is probably not so bad to exclude because it's kind of a weird thing and you can probably work around that. But not allowing size 1 batch, that's not so great. And the immediate thing you might think in this situation is, hey, well, I've got this model that works for any size that's greater than 1. Surely, it should also work for batch size 1, right? That seems very reasonable. And the answer to that question is yes, probably, but we don't know. For example, let's say you have a control flow in your graph that says if n is equal to 1, then do blah, otherwise do something else. Well, if you traced with batch size equal to 8, then we will never go down the path. And furthermore, we won't tell you that you had some user code and it decided to shunt you down this path. And you just won't know unless you actually go and manually look at the model to figure things out. And it's hard to imagine situations where so you can obviously create a synthetic example where this fails. It's a little hard to imagine situations where this actually matters in real life. The best example we could think of was the hand tracking model, where you either have 0 hands, 1 hands, or 2 hands. Well, if you 0-1 specialize on the number hands, then you only ever have 2 hands. Your model is never actually exercising the 1 or 0 case. Horace.
Right. Those are just another one, which is for sequence lengths, right? It's I remember, I think translation or something like that, they wanted a autoaggressive model where they started from no tokens, or a sequence length of 1 and then goes up to 2.
Okay, so are there any questions about the problem statement? Okay, I'm gonna try to put out this constraint, set up some constraints about how we need to solve this problem. So constraint 1 is I'm gonna assume we do care about exporting models where the dynamic, where you support n equals 1, but not n equals 0. I'm trying to make things a little easier for us by getting rid of the 0 null case. Does this sound reasonable to everyone? I'm especially looking at the expert folks in the room.
What does batch size equals 0 mean actually?
Well, so in an end-to-end model, this makes no sense, because if your batch size is 0, that means you have nothing to do inference on, and you shouldn't have called
Right.
the model in the first place. Now, that being said, there's also an internally in the model, you could be doing things like, computing a mask and then working out if the mask has any elements or not, right? And then do something different in the 0 case or not. So if it's data dependent, like whether or not you've detected any hands, that might actually be a thing. But I think for the end-to-end model flow, which is sort of what we're talking. Let me add this constraint. We're talking about end-to-end model inputs, not internal unbacked sentence. But in the end-to-end model flow, I cannot think of any case where you would actually want a sequence length 0 or a batch size 0. That just seems weird.
So it might apply to things like NERF. So there's models that are trained on very specific, let's say I can only generate a tractor, in which case it's not for your output, it's just generate a tractor, right? You already sort of the input is already encoded in the model.
Okay. So more constraints are, well, this one actually I'm not sure about. Okay, so this constraint is, I assume people don't want to remove one specialization and then fix all user code, library code, so that it no longer tests if the dimension in question is 1. I'm not sure about this. So, yes, go ahead.
Is the one specialization mainly because we want to reason about broadcasting based on the problem statement?
So based on my experience working on unbacked Simmons, the main situations where we lean on one specialization is, yes, broadcasting. Although broadcasting is not too hard to actually fiddle around with the guards so that you don't actually test if the thing is 1. So that is an overcomable problem. 2 is when we do contiguity testing and we do let me keep them separate. When we do contiguity testing, okay, sorry, broadcasting, but not so hard to fix in library. Contiguity testing. So when you do contiguity testing, there's a lot of special cases where if the size is 1, if the actual number of elements in your tensor is 1, then it's guaranteed to be contiguous, even if the strides are wacko. So it's very annoying. It's well, if so let me be concrete. So let's suppose I have a 1D tensor and its stride is 2000. Okay? So this would normally be a non-contiguous tensor because you have to jump 2000 elements every time. Unless its size is 1 or 0, then it's contiguous because, well, you only have one element or you don't have any elements. So, they are contiguous. So this is very annoying. And I also kind of think it doesn't matter in practice. This is an argument Horace has made as well. It's well, whatever, just say it's not contiguous and it's fine. But you are technically not having the same behavior as eager if you were to do that. And there's a thing about that for unbacked Simmons. And the last thing that it happens is also one of these really annoying edge case things is when you're doing stride computation, often you need to look at the if the size is 1 and then do something different for the output stride than if it's not. This is just a lot of rules, and the way we're running the system is we try to follow all the rules exactly, and so it slaps our hand whenever we're taking code that wasn't written with symbolic guardless execution in mind and trying to make it work for guardless execution. And if you fix these things, you can like do ResNet with variable batch size without doing a one test. So I know at least ResNet is possible to do, but it's just there's a lot of stuff you have to fix in practice when this happens. Pausing.
There's a lot of stuff need to be fixed. Like for example, in broadcasting, you not only need to check for one, you also need to check if two dimensions can be evenly distributed, divisible by each other. But that naturally covers one, doesn't it? Why is one so special? And it only covers some cases, in my
Well,
point.
broadcasting, there's no divisibility check, right? I can't add a tensor that's size 2 to a tensor that's size 4.
Why not? I thought that was a general broadcasting rule.
No, broadcasting only lets you do one size plus something.
So it's really mostly about one.
Yeah, so one is actually really special. Elias?
Yeah, I think this is more or less what you're saying, but I just want to call it more explicitly that yeah, I mean it's unfortunate that we're adding guards on strides when more or less like the backend doesn't care or like will do its own like with inductor like or other backends. We don't care what the initial strides are, and yet we're adding all these guards related to them. And if there's a way like it does matter in some particular cases, as with like the reshaping or views, but like I know there's work elsewhere to kind of make that not an issue. I don't know. So in an ideal world, would be able to ignore some of the striding guarding for export.
Yes, to restate what Elias is saying, if we have stride agnostic PyTorch, then it is okay for us to change what the stride computation is when we're tracing. And that will never cause like problems. And if you're exporting, you don't even care what the strides are because you're going to get rid of them all in the end. And so like, then there actually is a, yes, this definitely does not matter. Raziel?
So I just wanted to give some use cases. I think for N0 is a common thing for stateful models. When they check that the first iteration, if there is no state, then they tend to do something different on the model. And then for cases that are N1 or greater than 1, typically the check is because you could implement pipelining in the computation. So those are the typical things that people write if conditions and 0 and 1.
Okay, so I'm amending this constraint. So we do care about both the 1 and the 0 case, and I'm gonna add a constraint is we must detect n equals 1, 0 tests from user code for the above reasons, because they will actually do different things in that case. Sounds good. Vaz?
Hey, yeah, sorry I'm late. I had a question about strides and export. I think Elias's point makes sense. But is there ever a case where backends or exporter programs will require strides even without reshapes? Like they desire strides to know what PyTorch did, or is that just not a thing? Like, is there ever a case when we do want strides fundamentally?
Well, for executors, we're not using.
Yeah, but I know we aren't, but I'm wondering if it generalizes. Like, is executorch?
Yeah.
Like,
No, yeah. I mean that's a good question. Yeah, I was just giving that data point.
Yeah. I don't know enough about backends, especially export target backends, to know whether this is like just how we decided to do it, or whether this is a common pattern in the industry.
For inductor, real quick, like we use strides for the outputs just because of not having stride agnostic outputs, and then like we do use some strides on intermediaries for like deciding what conv to do, but I think in an ideal world we wouldn't use that, and we would tune like what strides we do ourselves, but it's like kind of just the current state of the world that we do.
Greg?
Natalia or Horace can correct me there.
So I guess I was going to ask a slightly more specific question than Vaz was asking, which is like, so contiguity testing, like I assume that's literally our implementation of is contiguous, like users aren't doing that by hand. So why can't we just do something special or different there? Like we don't actually care about the strides in that case, right? Because user code doesn't like yeah, the user never wrote that.
To try to answer your question, I think the answer to that question is yes. In the sense that in PyTorch library code, I'm never going to do a if is contiguous, do a completely different algorithm, or and if it's not, do something else. It's always going to sort of be semantics preserving in library code. So while so let's just imagine we're in stride agnostic PyTorch, then I think it would be okay to like change whether or not we report things as being contiguous or not. And this would not be semantics breaking. Like you would have the same semantics in program. It's just that we don't.
But I'm asking a slightly different question, I think, which is like, so I presume you're talking about like the actual implementation of is contiguous is like maybe looking at zeros and ones and things like that. But like you just care what is contiguous returned.
Yeah. So you're not proposing changing the definition of is contiguous, right? You're just saying, hey, like if it turns out that like it's contiguous anyway, then it's fine.
Are you saying to move it out of the numerical domain? Don't even make it like zero.
Yeah, that's right.
But you've got to figure out if it's contiguous or not.
But why do you have to guard on that, or not guard on that?
Sorry. So yes, so you don't have to. And in fact, I have a pull request which writes guard-free implementations of all of our contiguity tests. So you can in fact run them without guarding on them. But as Harz has pointed out, you're sort of just like pushing the problem to later, where like if someone does try to guard on the contiguity Boolean, you still have to sort of understand your like giant symbolic expression and figure out like if it's true or false, or error if you can't figure it out. Natalia?
Does stride agnostic PyTorch give us a way out of library code that actually relies on contiguity of tensors? Like people have all sorts of extensions that support only truly contiguous tensors. And even if we make the core PyTorch not care about it, and you can throw anything everywhere, the library code would still want the requirements on contiguity.
No, you're absolutely right. Like if I have a third-party function that takes in a tensor and it doesn't work if it's passed in a non-contiguous tensor, that code will no longer work. That being said, we would probably, they should probably have written .contiguous on their inputs. Okay. So moving the discussion along, these are some good constraints, and so Voz came out with a bunch of possible solutions. Voz, I don't know if you want to present this or if you want me to rip through them.
Yeah, I'm happy to. So let's talk about them. I think a few of these are yours. I can't take all the credit.
Some of them are, yeah, mine are on the bottom.
Yeah. So let's see, top to bottom. Making symbolic shapes smarter, where a symbol comes from. So we already have a lot of prior art on knowing where a variable is coming from in Dynamo with sources. And we already have sources in symbolic shapes. So it's not a crazy stretch to imagine that we could just write a lot of Dynamo style logic down there inside ShapeAmp that controls where the guards come from based on what the source is. So if it's, for example, control flow in user land, 0 or 1 would of course not be removed in any way. We would have to keep it. If it is coming from a stride and it's not direct access to user code, we could throw it out, etc., etc. You know, pros, obviously, that this feels like an extension of a system we already have. Cons is that is a lot of if else's, and it's probably brittle. And there are going to be places where we have a hard time differentiating between, you know, some combination of inputs a user gave to a library function versus just like top level user model code in their own control flow. And so this is like always on the table, but also wouldn't feel like the first thing I think we should reach for. Do you want to go breadth first or depth first, Ed? Do you want to like just go deep on this, or do you want me to cover the options at a high level?
Let's keep going because I don't see any hands.
Okay. Multi-export.
Actually, we have a hand. Okay.
So does the first option also solve the problem for non-zero and one constants, like a specialized inflow issue? If we can distinguish where, say, a potential constant is coming from.
I think it depends on the case. If it's like a user written constant, then you should be able to detect that. If it is a constant in a somewhere in library code, we may have a harder time saying, oh, this is specifically like a not user written constant that we don't care about, if that makes sense. Although I don't know if we have any such places.
What's the downside of option 1 actually?
Complexity, like it's a lot of if else's, it's a lot of logic to test and maintain. You're going to find edge cases for it all over the place.
For what it's worth, I actually don't know how to implement one. Like it's what exactly does this mean?
There's logic in setting up cards in Dynamo that reads the source and determines like, is it for the simplest one is an end module source is a category for.
Yeah, but when I generate a 0-1 guard, right, in general it can be on an arbitrary SymPy expression. You don't even have a source.
Wait, yeah, so is one about like where a symbol is coming from, or is it about where a like guard is coming from, I suppose?
Well, this is about where a guard is coming from.
Oh, okay. Well, we should reword this.
Yeah, that's fair. Because that's where it really matters, right? This is where you would apply.
Comes from library code. It's okay to suppress. If it comes from user code, we still want to error on it. Something like that.
Sure.
Wait, sorry, what does suppressing mean here? It's just like we assume it never triggers?
The same thing we do with 0 and 1s today.
We just don't report an error about it. So we're talking about the export workflow where we want to tell the user if they need a torch con something, but if it's in library code, then we're just going to assume that it's fine.
Okay.
I'm not even sure this is sound.
Yeah, I'm saying I don't know how I would write a lot of this logic. I feel like it would be full of edge cases. The other one is multi-export, which is just make 3 graphs. Specialize on 0, 1, and other for the DIMs.
Oh yeah, so I wanted to add a constraint, which is I assume executorch doesn't want 3 graphs.
Yeah, that's right.
Yeah, so this is just a write out. No.
Could you deal with 3 graphs?
Please no.
So, yeah.
This is what
I showed up,
TVN...
so all I heard is, "Could you deal with 3 graphs?" And I'm like, let's not
what
go
if
down.
What if it was 1 graph with a?
We were just waiting for you to join, Michael, and Vaz was prepped
I'm ready for you. Yeah, I kind of don't like this idea either. But what if it was 3?
Well, we've got a lot of other
graphs?
options, so let's just move on in that case. So what exactly is autocond?
This is install cog automatically in the places where there is user control flow for 0 or 1.
This is like kind of orthogonal, right? Because if you can report the error in these locations, the user can always do it manually. So automatically putting in TorchCon is like a bonus on top.
Mm-hmm.
I don't know if anyone has temperature on this.
I'm assuming, like, is part of the argument that you would also want to do that to library code. That way, it's like you just get one giant graph, even if library code does different things on 0, 1. Or is the argument that this is just a user code thing?
I think you'd start with user code, but I don't see why you wouldn't just do this.
Or I guess my opinion is that this seems like really hard and feasible. Like I just don't see how we're going to be able to do this. Like, you know, just something like broadcasting, right? Like the output shape is like different depending on whether you go down the one case or the not one case. And like I feel like this like breaks a lot of our con assumptions, right? Like I don't think we can handle if like the output of the con is like arbitrarily different shapes. And like my understanding is that's like currently a constraint that we have.
Okay.
Yes.
Let's kill this one. Okay, reject graphs with users specified. Oh, what's up?
Oh, I just want to say before TVM does the multiple graph things. Like, you know, I'm not saying it's necessarily ideal, but like you could imagine, like particular models that like want to do full static specialization on like a couple shapes and then dynamic elsewhere. I don't know necessarily, but there are other people who do this. I don't think it's like so terrible depending on the use case.
So it's described as terrible, but if you combine it with the way and pervasiveness that we do 0, 1 specialization, it seems like a little doomed. I don't know.
We could hide it from you, though. You could have one single graph exported with like a just control flow for the various subgraphs in it. You just maybe would never enjoy it.
That seems worse.
Yeah, I'm not trying to sell this.
Is actually only 3 graphs? Are there any combinatorial explosion situation where there are multiple?
Oh, absolutely.
Explosion
Yeah, absolutely.
Or
So
like
it's 3 to the
my
power
issue
10.
with 2 is that it just seems like a stupid thing to do. Like if your graph is like the same, then why are we just exporting the same graph? Why don't we just export one?
Because it might not be the same. For it's worth, I'm not that into 2 either. This is just like, you know,
yeah, I think
the ideas out.
So 4 is reject graphs with the user specified control flow ops or ops that change graph stuff with 0. This is basically the sum is 1, right?
Kind of. This is more like error out when you see it. You just go, you can't do that.
Right. But that's the point, right? We're like, if you condition on it in library, it's fine. But if you do it on user, it's not. ?
Kind of. I thought of the first one as like controlling which guards get made. And this is more like we don't even go into figuring out which guards get made. If we see it, we throw it.
Okay. Okay, moving on. Reject graphs, but allow a re-enablement of them with constraint-like systems. Yeah, so this one is basically saying, hey, what if we disable 0, 1 specialization for things you marked as dynamic dim? And then you get a bunch of guards, but like, you know, you can in principle massage them. This is why I was asking about like, do people actually want to just fix the library code so that it doesn't test the dimension? This is essentially what you have to do with an unbacked cement if you don't want to like say that, you know, the non-zero number of elements is greater than 1. So what you do is you turn off 0, 1 specialization for the dynamic dim, and then you keep fixing errors until no one is guarding on it anymore. So the pro of this is it's definitely sound, but Yeah, it's a lot of work.
It's also annoying to do, like as a model author, because this specific implementation is for 5 is not the same as your unbacked one, because you're doing unbacked and library code. This is at like pre-torch compile code, which is arguably worse, right?
Mm-hmm. Greg, did you have a comment?
It was relevant before Voz said what he said.
Okay.
So.
And then option 6 is YOLO, do nothing, and option 7 is option 7 is this weird technical option, which is essentially when you have a symbolic shape, so if you 0-1 specialize, then we can discharge a guard that way. If you then have a symbol, you actually know that it cannot be 0 and 1. And we make simplifications based on this. So you could just turn off that part of it. And this is just a very like technical proposal, but it's not, I mean, it's I'm not sure how much it actually helps.
So I think my proposal is not exactly like, or like my proposal is probably like closest to 6, or and that like I think we should do like basic like, or it's kind of like 6, kind of like 5, and that I feel like what we should do is that if a shape is not like, if at trace time the shape is not 1 or 0, then in all of our library code we should like go down the path that always assumes it's not 1 or 0 and basically just remove those guards. But you know, we don't have to do this for user code, or like we shouldn't do this for user code, and we should just do this for library code and all the places that we see it. Like,
Just a question, like, can you ever make an assumption that it's this or that? Like, let's say for something like inference, like you have some sort of dynamic batch. If you have, oh, sorry, I see Natalia raised her hand for. Sorry, I'll shut up.
No, I raised my hand after you, so go ahead.
Yeah, so I'm wondering, like, in the case of like dynamic batches, you have like some delay, and you're like, okay, well, what's available in this batch? And that might be 1 or it might be more than 1. So I just don't think it's this or that.
But this is for rank, right? Like it's fine if or am I crazy?
I don't know what you mean by rank.
Oh, this is like 0, 1. Oh, never mind. I'm crazy.
Okay, Natalia?
What does it mean at trace time? Isn't like this whole problem because of unbacked cements that we have no idea what they are at trace time?
Oh no, so the unbacked cement is similar, but in the export use case for the end-to-end, we do have a concrete batch size we're actually going to be tracing against. So we do have the size hint here.
like maybe rephrase another way. I think in all the cases that like basically for like 1 or like that we're checking for 1 and 0, we should just like, unless we have concrete information that this is 1 or 0, we should just assume that if it's dynamic, we can assume it's not 1 or 0.
Greg?
I don't understand why we can't like do this soundly in a way that's not super difficult. Like, how many places do we have that like you'd actually do something different? All you need is like an indicator that you're like, or a good API that's like, yeah, we're not doing anything differently. And you don't need like magic across figuring out if you're in library code or user code. Like, I don't know. Does that make sense?
Let me think. Let's so some examples of, so Greg, to make sure I understand you correctly, you're basically saying, hey, like, surely there aren't that many places we've got to update, and we can just update them, and then like.
Yeah, and I'm only talking about library code. Yeah.
Yeah, library code. Yeah, so I mean, it is feasible ish. Like for example, this is pointwise operations broadcasting, and like this is like the naive code that guards, and then here's the fancy code, which basically is just like be very careful not to accidentally guard until you've tried all of the easy things first, and then be willing to insert guards on things. Like this was not too hard to do. Oh, this is not even the full PR.
But like, I'm not even sure that you ever need guards. Like, yeah, if you literally look at this code, you need guards. But like, what's calling this code?
Well, infer size is being called by a pointwise op, which is trying to figure out what the output size of two pointwise.
Okay, but what's calling that code? Like, is assuming not 0 and 1 ever going to be?
You wrote a pointwise op in your model that you're exporting, and we're propping through it.
Right, and the pointwise op on the backend should just do the right thing in that case. Like, what is my guard preventing me from doing incorrectly?
Well, as I said, with broadcasting, it's not. It's like because in the normal case, one of these will be statically known to be 1, and you'll be fine, and there's no guard, and you can do this case 100% soundly.
Yeah. So I guess what's a case where like we couldn't do this and would really need guards?
A case that you can't do 100% soundly is so there are some that are like sound if you have stride agnostic PyTorch. Let me think. Do I have the example here? Okay, I'm going to make a claim, which is on ResNet, if you are stride agnostic, you can do the entire model with dynamic batch size without making any unsound decisions. So what I mean by that is either you can be careful and just not guard because it was unnecessary, or the guard was only to like sort of disambiguate between some like pedantry on how the sizes should be, the output strides should be. But we said we're stride agnostic, so it doesn't matter if the strides wobble. I ran this experiment like this week, so I'm pretty sure this is true.
Would there be any way to verify that more broadly? Because like,
we'd have to try it on more models, essentially. Okay.
Yeah, I guess my intuition is just like, yeah, maybe you need stride agnostic PyTorch. I'm not 100% sure, but my intuition is sort of like none of these that we can both do this soundly and quickly. I don't know what the other side of the argument is, but that like most of these things don't actually matter or are that difficult to change.
Any more comments? Okay.
Or like I agree with Greg in that basically like my my driving intuition beyond this problem is that this is a stupid problem in that like none of the like we don't expect anything we're guarding on for 0 or 1 to actually like dynamically change at runtime, right? Like we don't expect dynamic broadcasting. We don't expect like dynamic contiguity checks that like differ between one run versus the other. And so why are we having so much difficulty with dealing with this problem? And it's because like spurious checks on like 0 or 1 that don't actually matter. And so to me it seems like the easiest way to deal with the spurious checks is to just define them out of existence. And I think it is true that like it is possible for user code, like in the hands tracking case, to have 0, 1, or 2. And so I think it makes sense to have like differing rules for different variables. But like I think for like most shape variables, like 6 seems most feasible. And I guess the other problem here is I feel like all the other ones, like all the other solutions here seem not great. Like there's nothing here that seems very appealing to me.
Greg?
So I think I have the same intuition. I just want it to be sound because if it's not, then like we're always like literally every post in like PyTorch 2 Q&A, someone's gonna be like, oh, is this because we made some like unsound assumption somewhere?
It seems like I mean, having not looked at a ton of the model code you guys are looking at, it seems like the most common sensitivity, like dynamic sensitivity, would be, people checking for 0 and then not doing something, like circuit breakers based on emptiness or whatever. Is that something that people actually do, though?
Sorry, is this a question about models?
Sorry, say it again, Ed.
Is this a question about models?
Yeah, question about model code.
I can't answer because I only know what's going on with ResNet because that's the only one I actually did seriously.
Okay.
Okay, let's table this topic for now. I think there'll be more discussion about this going forward, but it does sound like we know what general part of the solution space we want to be in. Okay, Michael, so I feel bad dragging you into this meeting. Do you want to talk about your doc or do you want to just talk about, actually, should we even talk about
I like coming to this meeting. You didn't drag me
Okay,
here.
should we talk about your doc or should we talk about training export? Those are the like two of the possible things we could talk about.
Well, we have 8 minutes,
Yeah.
so maybe neither. I don't know. We can talk about training export, or actually, let's talk about the inference doc because I feel like that one is less in the weeds. So maybe we can cover it in 10-ish minutes.
And just a reminder, this is a publicly streamed meeting.
Maybe we shouldn't talk about the inference doc. All right, I have nothing further to say on any matter.
We have that meeting tomorrow afternoon. We can use that time to discuss too.
Okay, that sounds good.
That's private. Yeah.
All right, then let's use the last 8 minutes to get to a resolution on this topic then. Okay, Vaz, you were you wrote the first version of this doc. What do you think? Where do you think we are right now?
Well, I know where we definitely aren't, which is at a consensus. But I think that if I had to go with one, 6 is very compelling. But Greg's sort of warning at the end is also very
actually let me try to recast what I interpreted Greg's proposal as. So basically, to do it Greg's way, what I would do is I would turn fine-grained dynamic dims into honest to goodness unbacked ints. So it's as if you had like called non-zero on something and then now you're feeding it in. So it's unbacked and every guard on it is an error. And then what you do is you just fix library code to like not do dumb stuff until your model traces.
Yes, I think that's extremely compelling for an export perspective, where there's already a lot of iterations compared to like eager. Eager, you slap on the one-liner and you're like, it ran, and you don't really think too much about the graph breaks and those stuff unless you're trying to squeeze perf or go to prod. With export, there is like it's already not a one and done kind of thing, right?
Natalia.
But we are not in stride agnostic land yet, and we can't even realistically be there for channels lost, because for channels lost we are checking honest to goodness strides. So what are we going to do until we come to stride agnostic?
So let me think. So so one of the reasons why stride agnostic was a lot of trouble is because in eager we had graph breaks, right? And then it could go into arbitrary code and we didn't know what it was doing. Export isn't like that. So now I'm going to make this claim, which is that when I'm exporting a model, as long as I don't wobble the strides such that the exported model now like raises an error, and the exported model doesn't have like an as strided call in it, then export is stride agnostic today with no changes.
Are you asking? If so,
Yeah,
I
I'm
agree.
asking. I'm making this claim, and people should challenge me on it if it's not true.
Is that maybe true modulo like the reshape stuff?
Well, so basically, like I'm just defining away the problem, right? So with stride agnostic program, we said, well, there's three things that cause problems because strides wobble in practice, right? As strided, reshape / view, and there was one other thing that I can't remember. Oh yeah, mutating through contiguous or something. So my claim is that in export, probably these don't happen, and it's probably okay. Like if you're willing to accept these as the limited set of possible soundness issues, and we can also like it's easy to check for as strided in user code. It's not so easy to check for mutating through contiguous, but that's probably fine because people are probably like the code is written shittily. So you can also just fix the code to like not do crappy stuff like that. And then we just need some sort of lint to detect it.
Yeah, I mean, my sort of overall thing here is like, I don't want us to get. I kind of am with Horace on this. Like, if this is not a real problem, like this is kind of a problem that we've created because we know a lot about the system and the corner cases, then I would prefer to define it out of existence. I mean, in general, right? Like striding is undefined in export, right? We kind of just like we expect it to be kind of flattened away, and the user shouldn't really be able to observe, or the backend shouldn't be able to observe any sort of differences in striding. So if we can leverage that property to be like, yeah, you know, whatever, we'll just like rewrite it to flatten everything out, then sure. I don't know if we can. I don't really understand what you were talking about.
Can we not check all those cases that you're talking about, Ed, if we know we're exporting?
Well, so as strided is easy. Mutating through contiguous is not so easy, but you know, if Mikey gets far enough along with stride agnostic, he will have that check. And view reshape raises an error, so it's not a soundness problem. Yes.
Yeah. So why is the check hard? I get that, like the whole thing is hard.
Oh, you can do an easy check that has too many false positives, and maybe those false positives don't matter for export.
Yeah, and I'm saying like only run those checks in export.
Dark ritual.
Yeah, my question is like following on Mike's point here on like we should not care about these cases if they don't actually happen. I'm curious what's your state of mind of like we should error out, or is it okay for us to do whatever?
So specifically, if we are stride agnostic, then you can resolve issues regarding contiguity tests and stride calculation by just doing the thing Horace said, which is just assume that it's not 0 or 1. And this will diverge your model behavior from eager, but in a way that only affects the strides. And so like, okay, and whether or not it reports is contiguous. I'm not sure about that one. But essentially, it's a much more limited set of behavior changes, which we like kind of are able to, describe coherently in a short sentence. Natalia.
But reporting is contiguous shouldn't be a problem, right? Usually is contiguous is just a precursor to calling contiguous, and we know what we want to happen.
Yeah, okay, so let's say contiguous is also fine, and we don't care about that as well.
Yeah, I can jump in with a basic. Yeah, like I think we can say export is stride agnostic. Like the export spec does not define what like strides are or what views are intentionally, right? Because we don't expect backends to really have any clue how to implement that. So if that's a way to simplify the issue, like we can do that.
Well, doesn't the previous discussion on hint only stuff apply here? That means we are sure that it's stride agnostic. It's not undefined. It's defined, and we don't care.
Yeah.
The thing about guards emitted for export is you can just ignore them, right? Like if you know better about your backend, you can just be like, the stride guard's not for me.
No, I don't understand. You don't know it's a stride guard.
Why not?
Because all you get is oh, this simply expression has to be equal to 1.
But when it gets rewritten as a guard via source, it'll say
No,
x
but
dot.
it may not be, because the strides of intermediate tensors may depend on sizes. So like once you work out the source in the end, it could all just be size sources.
I see.
Okay, so the resolution is we're going to YOLO do nothing, and we're going to make these dynamic dims actually unbacked. Okay, Vaz, we should talk a little bit about this, I guess, because
Sure.
this has implications. But this is a real technical plan. Like this actually does solve the problem. Okay, we're out of time. Oh, Elias.
Yeah, I just like I agree that having like sort of explicit rewrites and stuff is a good like short-term plan. But I did also want to just say like there is a way to do this without like explicit rewriting, which I think like Ed and some of us have talked like just a bit about, where like you kind of speculatively look at multiple branches and see that the like result is the same regardless of the guard. And it'd be like annoying to do. I don't think we should do it in the short term, but like there is a path forward that way.
Okay, thanks everyone. See you all next week.